Hey guys, so I'm going to go over lesson 1.2, part 1. We're going to talk more about this lesson in class on next class, whatever day that is. So today's objectives are going to compare and contrast the benefits of different sampling techniques, including random sampling as well as convenience sampling methods. So we're going to start with the first type, the most basic type of simple or random sample we can take, which is called a simple random sample. So our basic procedure for this, and don't forget about the notes. If you open those up, you can kind of fill in the words on there. So our procedure for that is we would put all of the individuals in the hat. Remember, individuals are people or objects or animals that are in our population that we're interested in. And really, you wouldn't put the actual individuals in the hat. You would probably put their names on like slips of paper, put the slips of paper into a hat, right? So you put all of the names of the individuals into a hat, you mix them well, stir them around, then you draw until you get enough for your sample. So if you have 100 people, you put all 100 names on slips of paper, put them in a hat, mix it around, take out 10, maybe, however many you want. You want to make sure and ignore repeats for samples. So in this case, with the hat, that would mean that you don't put a slip of paper that you already picked back into the hat because you don't want to pick it again. You want 10 different people to be in our sample. And then you would end up serving every individual you drew. So whoever got their name pulled out of the hat, you would then survey. This way of doing it is called the hat method because we're putting things in a hat. That gives us that randomness because then it's not us picking the people or individuals. It's completely by chance. And that's what we want in a random sample. We want our sample chosen completely by chance. So that is the simple random sample method. So why is this method preferred for random drawings? The main reason is because all outcomes are equally likely to happen. And that's good because we want to make sure that every person or every individual in our population has the same chance of being chosen as anyone else. That makes it fair, I guess is one way to put it. So all outcomes are equally likely, and we want in a random drawing for every single person to be equally likely. So simple random sample is good, but it's not always the best method. It's not always going to work super well. There are some situations in which a simple random sample might take too long or whatever. So the following examples I gave you, I want you to think about what challenges would this simple random sample method present when we're dealing with the following populations. So students at a high school. So for students at a high school, it might be difficult to get all of our student names to put on pieces of paper into a hat. That might take a really long time, and there might be a better way of surveying or picking a sample of students at a high school. Students going to prom. Well, we don't always have a list of who's going to go to prom and who's not. People may buy tickets in advance, but then sometimes people come to the door. So we don't always have a solid list. Customers at a grocery store. Well, customers at a grocery store are constantly moving, and we don't have a list of them. They're not all going to be there at one time. They don't sign up for times to go to the grocery store. They just kind of come and go. So it would be hard for us to get all of their names to put on slips of paper to put into a hat. That would be really difficult. And then trees in a forest. If we wanted to sample some trees in a forest, well, it would be really difficult to know how many trees there are, give them all a number or a name, and then put all of those names in a hat. That would just take a really ridiculous long amount of time. And surely there's a better way of getting a random sample of trees from a forest besides just numbering them all or naming them all and putting all their names in a hat. So simple random sample is obviously a really simple way to set up a random sampling process to make sure that we get a good, fair sample. But it's not the only way. So another way that we could do this is with what we call a cluster sample. So a cluster sample, you kind of see this image, we have clusters of people. So it's about grouping. So a cluster sample is when we have groups of individuals that are located near each other. And that could be geographically, like they live close to each other. If we're talking about schools, we may be looking at like students' homerooms or their first period class, or something where they're kind of already near each other. In the city, we might say like city blocks, people who live on the same block, or in the same zip code, or in the same area of town. So an example of a cluster in a high school would be classrooms, like I said, like maybe your first period class, maybe bus routes. We could put everyone who's on a particular bus route and people who live in specific neighborhoods. So a cluster is just kind of individuals, groups of individuals that are located. So what we do with cluster sampling is instead of numbering each individual person or each individual, I would number each cluster. So I would put all of the so there's our little cluster drawing. I would put all of the cluster names in a hat. So maybe I'm talking about like first period classes. So I would put all of the like room numbers where there's a first period class, and I would put those on slips of paper and put them in a hat. So I'm putting the group names, the cluster names in a hat. I'm going to mix well. I'm going to draw maybe just one class, maybe two, maybe I'll do 3 classes. But I'm going to draw until I get my sample, however many I want. I'm going to ignore repeats. And then I'm surveying everyone in the groups that I drew. So everyone gets surveyed in the clusters that got drawn. So instead of picking individual people, we're picking clusters or groups of people and then surveying the entire group that got picked. So that is what a cluster sampling is. We put people in groups, we pick entire groups to be our sample. Randomly, of course, and that's what the hat thing is about. So why would this method be preferred to a simple random sample? Any thoughts? The biggest thing is that it's easier. And a lot of times in real life, when we're talking about real statisticians who collect data, it's way cheaper and it takes way less time. So when we're talking about a really, really large population, like maybe trees in a forest, it's going to be a whole lot easier to do something like a cluster. So maybe they'll take certain acres of the forest or just certain areas of the forest and pick one area and then use all the trees in that area. That's a lot quicker because then they don't have to like go all around to all the different places to get all these trees they picked. They just have to go to one area and look at all those trees. I don't know what information they're getting from the trees. I'm just using that example. So example 1, we're going to look at kind of a difference in a specific situation on how I would set up a simple random sample versus how I would set up a cluster sample. So let's say we wanted to survey students seated in the cafeteria. So students in the cafeteria is our population, and we want to draw a simple random sample. So remember, simple random sample is the simple one. We number everybody, we put all of those names or numbers in a hat, mix it around, pick some, that's our sample. So in this case, I would number every seat in the cafeteria. I would put all seat numbers on little slips of paper and put it in a hat and mix it up. And then I would draw seat numbers without replacing it because I don't want the same one twice. I'm going to draw seat numbers until I have however big my sample is going to be. So I've numbered every single seat individually. I put all the seat numbers in a hat and mix well. I draw out my sample. So that would be a simple random sample. There's no grouping involved. There's nothing that happens first. I'm just going straight to numbering, putting it in a hat, and drawing. We would survey the students whose numbers got picked. But if we wanted to do a cluster sample of the students seated in the cafeteria, instead of numbering each individual table or person, I may number each table. So the tables then are our clusters. So instead of having to look at each individual seat, which could take a long time, I'm now just numbering the tables. So I'm making this easier on myself. So I number every table. I put all the table numbers on slips of paper into a hat and mix it up. I draw table numbers without replacing until I get the desired sample size. So if each table has like 10 people in it and I want a total sample size of 20 students, I might pick 2 tables, right? And then every student at the selected tables gets surveyed. The simple random sample, I'm picking individual seats. I have to number all the seats, and then if the 10 people I pick or 20 people I pick are all over the cafeteria, I have to walk all the way around and survey each of them. Whereas with cluster, I'm numbering the tables, I pick 1 or 2 tables, and then I just have to go to those 2 tables to survey. So cluster is a lot easier, right? It's not always better, one thing I wanted to mention. Cluster is easier, certainly, but it's not always going to be the best. If you think about cafeteria, and usually you're sitting with your friends at the cafeteria, and depending on what our survey question is, everybody at that table might feel exactly the same way. So we may not get a very good random or fair sample doing it with a cluster method, but it is a lot faster. Then we have stratified sampling. So another way that we can do a sample, a random sample, is with what we call stratified. This is also a grouping method. And you can kind of see based on the picture. We still have groups, but what you may notice is different this time is firstly, the groups are not all necessarily the same size. And they don't have to be with cluster either, but with cluster, they looked closer to the same size of groups. With stratified, one thing that's different is that they're based in groups like on some kind of similar characteristic. So I can see that these are all the same type of person. These are all people with a little baby. That looks like mom and dad with a baby, or a couple with a baby. And then that looks like a couple with 2 kids. And that looks like an old person, right? So we're splitting them up into strata or groups based on some similar characteristic, right? In this case, it's like stage of life. So a strata is a group or class in a population that share some common characteristic. That common characteristic could be age, it could be gender, it could be whether or not the person wears glasses, could be what color shirt you're wearing, etc. So it's something, we're grouping people together based on some similar characteristics. So in a high school, some example of strata that we could separate into groups based on something would be maybe grade levels, right? We could separate 9th, 10th, 11th, 12th. We could do groups based on ethnicity. We could do based on how do you get to school. Not that anybody's going to school right now, but you know. And then we could even look at it as participation in school events, right? So we separate people based on some similar characteristic. And then what we do, and this is a little bit longer, stratify, you may already notice, it takes a little bit more time. So cluster made things easier. Stratified is probably going to end up taking you longer to do, but there's a reason we would do it. So what we do is set up a hat for each strata. So we have all of our different groups. Let's say we're doing 9th, 10th, 11th, 12th. So I would have a hat for each grade level. Then in each hat, I'm going to put all individuals. So I'm going to put all of the 9th grader names in one hat, all of the 10th grader names in another hat, 11th graders, 12th graders. And then I'm going to mix them well. That's the random part, that's making sure that it's fair. Then with each hat, we're going to draw however many we want, randomly mix it around. Don't get the same one twice. So we will draw until we get the sample we want. For that strata, we ignore repeats. And then after you do that for each group, for each strata, we're going to survey everyone that we've picked. So the idea behind a stratified sample, yes, it's taking longer. I have to split them up into groups first. I have to do a hat for each group. It's going to take longer. But the benefit of doing a stratified sample is that we make sure that each group is represented because we're picking from each group. So if I'm doing a survey where I think like 9th graders might feel differently from 12th graders and I'm going to get some differences of opinion, I might want to make sure that I'm getting some of each grade level. A stratified would make sure that I get each grade level, whereas like a simple random sample, when I just number everybody and pick out 10 or 20 numbers, I may end up getting all 9th graders. And then my survey has no representation from 12th or 10th or 11th graders. So that's the benefit of stratified, is that it guarantees that I'm getting equal representation from every group. So here's an example where we're talking about hotel rooms. It says an 8-floor hotel has 30 rooms on each floor. It has 96 of its rooms facing the ocean, another 48 with a partial ocean view, 96 facing inland. Room numbers have the first digit from the floor number, and the next 2 digits range from 1 to 30. So rooms on the first floor would be 101, 102, 103, etc. Rooms facing the ocean cost the most, partial ocean views cost the next, and inland views cost the least. So which strata could we use? So again, the idea behind stratified is that it's guaranteeing equal representation from each group. And that would only be important if we think that each group might have either a different opinion or a different experience, and we want to make sure that we are including each group. So in this case, rooms on different floors don't really seem to have much of a difference. There are rooms on each floor that has ocean, inland, or partial ocean. Right? So there doesn't seem to be much of a difference on rooms from one floor to the next. What does seem to be different is the view that you have, because the view is going to cost different amounts. So I would use room view type because of the different pricing. So floors don't really have much of a different, any kind of differences, but room view type does. So how could I draw a stratified sample? Well, I could set up a hat for each view type. So I have a hat with all the ocean view rooms, hat with all the partial, hat with all the inland rooms. Then I would mix well, and then I would pull ocean numbers in the ocean hat. Oh, I'm sorry, this says put all ocean numbers in there and mix well. Draw room numbers until you get the desired sample size, and then ignore repeats, and then do it from each of the other two hats, right? So I'm making sure to get a random sample from each group to make sure that each group is represented, right? The last type that we're going to talk about today is called a systematic sample. So systematic is called that because there's kind of a system to it. Systematic is good because sometimes there's no really easy way to do any of the other methods. Think about if you have people in a really long line and you wanted to survey them. That line's going to stop and start and end. People might get in the line and then get back out. Someone may not get in the line until like the very end of the day. So that population is a little fluid. It's flexible. It's not the same all the time. So getting all of their names or numbers to put in a hat and then mix is not going to work. So systematic sampling will help us with that. So systematic sampling means that we're creating a sample by selecting every nth, where n is some number. So every first or fifth or every 10th or every 25th or every 100th individual in our sample. When might we want to do a systematic sample in a high school? So lunch lines, like I said, any kind of line where people might be coming in and out and in and out is good because I may not be able to number them all, and this is a good way to do it. So students coming out of a library or out of a cafeteria or out of any place, because we may not know how many kids are in there, so we can't really number them all or put all their names in a hat. I always give the example of like if you wanted to survey people who go to HEB on Saturdays. Well, everybody who goes to HEB on Saturdays is not going to be there all at one time, and they're not going to stay there long enough for you to number all of them and put their numbers in a hat. They're going to come and they're going to leave. So systematic gives us a way to just survey every 10th or 20th person that comes in. So then I'm kind of doing that throughout the day instead of trying to do it all at once. Okay, so our procedure for a systematic, I'm going to put the numbers 1 through n. N is just whatever. If you want to do every 10th, n would be 10. If you want to do every 20th, n would be 20. So you would put every the numbers 1 through n in the hat and mix well. So n is the frequency, like how often you want to do it. You're going to draw the starting point, right? So you have 1 through 10. You're going to draw one of those numbers, and that's going to be your first person in your sample. And then you'll sample every nth after that. So let's say I pick number 7, right? That's my first one. And then I would do every 10th person after that because n was 10. So let's say you want to survey every 20th person in the lunch line. So first you would put numbers 1 through 20 because n is 20. We want to do every 20th. We'd put numbers 1 through 20 in a hat, mix well, draw one number to select the starting point. And then once we've selected that person, we would do every 20th person after that. So those are all types of random sample. They all involve chance. We put numbers in a hat, we mixed it around, we took some out. So all of those options, they're going to be good in some places and not in others. There might be some ways where we use one over the other, but they all involve randomness. So they should all somewhat give us a kind of fair sample that is a good representation of our population. But then we have this thing we call convenient sampling, or sometimes it's called judgment sampling. So this is the one type of sample that we should avoid because there's no randomization. There's no chance being used to pick that sample, right? When we use, and we haven't done this activity yet, this is referring to, but when we use convenience or judgment samples, the estimate for our parameter, which is the thing we want to know, is more biased than when we use randomization. So an example of convenient samples if you just survey the people in your statistics class, right? So if your population is like all students and you just survey the people in your class, you didn't attempt at any point to do any kind of randomization. You're just choosing people that are convenient to you. And that may lead to some bias. The people in your statistics class may feel differently about whatever question you're asking than the rest of the people in the school. Plus, you're getting mostly older students in that case. You're only getting maybe 11th and 12th graders, so you're getting not really anything from the younger students. If you leave customer satisfaction surveys in the lobby of a hotel, right, you're doing what's convenient for you. That's an easy way to take a survey, but only the people who feel like picking that up and filling it out and putting it back down are going to respond, and then you're not getting a good representation. We all know that the people who take the time to write satisfaction surveys are either like really mad about something or they're really, really happy about something. We're not really getting a good view of what's really true. And then the grocery store manager surveying the first 10 customers who come. So the first 10 in the door, that's all he does. That's not necessarily going to represent everybody. We're missing out on a whole lot of people, and there's no randomization at all. So convenience sampling is not a good way to take a sample. It's super easy, but it's not going to give us good data at all. And it's not really trustworthy data that we get because there's going to be bias. And we'll talk about bias more in another day. So that is it for today. I know that was a lot more than the last lesson. So hopefully you stuck it through with me. And we will talk more about these types of sampling in class on Friday/Monday. Got my days mixed up. And yeah, so thanks guys. Have a great day.